In the quiet solitude of our world, sheltered beneath a thin membrane of atmosphere, we have cultivated a very particular idea of what it means to be alive. It is a story written in water and carbon, a delicate ballet of organic chemistry, unfolding on a gentle, sun-drenched stage. Our minds, the most complex structures we know, are products of this fragility. They are born of warm, wet, stable environments, intricate electrochemical symphonies played on instruments of soft tissue. From this singular vantage point, we gaze out into the cosmos, and what we see is a terrifying, magnificent, and utterly alienating spectacle. We see a universe of extremes, a realm of fire and ice, of pressures that could pulverize diamonds and vacuums that stretch for light years. It is a dominion ruled by forces that would annihilate our form of existence in an instant. And so, we ask a question born of both loneliness and hubris. Are we the only ones thinking in this vast, violent expanse? Or is that very violence a forge for other kinds of minds? Minds so profoundly different from our own that they might not only endure the universe's extremes, but be born of them, thriving in the very crucibles we deem uninhabitable. Could an intellect take shape in the heart of a star? Could consciousness crystallize in the absolute zero of interstellar space? Could a mind endure the gravitational torment of a black hole's edge? This is a journey not in search of little green men, but in pursuit of the fundamental limits and possibilities of cognition itself. It is an exploration into whether the universe, in its most hostile corners, is truly empty, or if it is simply singing a song our biology is not tuned to hear. Before we can venture into these cosmic infernos and frozen voids, we must first dismantle the architecture of our own assumptions. Our very definition of life is a profoundly local phenomenon. It is a definition built upon a sample size of one, Earth. We imagine life as cellular, DNA-based, requiring liquid water as a solvent, and carbon as its structural backbone. This carbon chauvinism has long been a comfortable anchor for scientific thought, but it may also be a set of blinders, preventing us from seeing the truly alien. Consider the simple element of silicon. Sitting just below carbon on the periodic table, it shares a crucial chemical property. It can form 4 stable bonds, allowing it to create long, complex molecular chains, the very foundation of our own biology. For decades, visionaries and scientists have speculated about a silicon-based biochemistry. Imagine a world far colder than our own, perhaps a place like Saturn's moon, Titan. Here, liquid water is as hard as granite, but liquid methane and ethane flow in rivers and seas. In this frigid domain, a silicon-based metabolism could, in theory, proceed. Its biological processes would be achingly slow, a geological timescale of thought and action. A creature born of silicon might perceive 1,000 of our years as a fleeting moment, its consciousness a slow, crystalline process, its thoughts like the growth of a glacier. This is not merely swapping one element for another, it is a fundamental reimagining of existence. But even this stretches our definition only slightly. It is still chemistry, still a body. The truly radical question is whether a mind requires a body at all. What is a mind, if not a pattern? Our thoughts, our memories, our sense of self, they are not the specific atoms in our brain which are constantly being replaced. They are the intricate pattern of connections, the flow of information through a complex network. If the pattern is the mind, then could that pattern be sustained by other substrates? Could a consciousness exist as a shimmering, self-organizing plasma cloud in a nebula, its thoughts articulated in bursts of electromagnetic energy? Could a sentience arise within the crystalline lattice of a planet's deep mantle, information propagating through piezoelectric charges over millions of years? This line of inquiry leads us to the precipice of understanding mind as pure information, a phenomenon independent of its physical vessel. Think of it like a magnificent sculpture. We see the marble, the bronze, the wood, and we might mistake the material for the art. But the true art is the form, the idea, the pattern impressed upon the material. That same form could be rendered in light, in data, in sound. The universe is filled with materials, with energy, with complex systems. Perhaps it is also filled with sculptures of consciousness, carved from media we have not yet learned to recognize as a canvas for thought. Let us begin our journey in the most violent and energetic place we can imagine, the heart of a furnace that dwarfs all our conceptions of heat, a star. To us, a star is a thermonuclear bomb held in a delicate gravitational balance. Its surface seethes at thousands of degrees, its core at millions. It is a place where matter itself is stripped down to its core components, a raging sea of plasma, of naked nuclei and liberated electrons. For any form of chemistry, let alone biology, this is an absolute non-starter. Our molecules would be obliterated, their atoms torn asunder in less than a nanosecond. But what if we are thinking about the wrong kind of life? What if a mind did not need molecules? In the 1950s, physicist Robert L. Forward, a true visionary, began to ponder what sort of complex phenomena could exist inside this inferno. He theorized about life based not on chemistry, but on nuclear physics and magnetism. Imagine complex, self-replicating structures made not of atoms, but of magnetic fields. These entities, which we might call magnetovores or solarians, would be vast, ephemeral beings of pure energy and plasma. Their bodies would be intricate, self-sustaining magnetic domains, feeding on the star's immense magnetic flux and thermal energy. Their metabolism would be the manipulation of nuclear reactions. Their thoughts, their consciousness, would not be the firing of neurons, but a complex dance of interacting magnetic fields, a symphony of electromagnetic waves propagating through the stellar plasma at the speed of light. A single thought for such a being might be a flare of energy the size of Earth. Their society could be a collective consciousness woven into the very fabric of the star's corona, a mind whose scale is planetary, whose lifespan is measured in the billions of years of its host star. To us, a solar flare is a random burst of chaotic energy. To a Solarian mind, it could be a word, a sentence, an idea being expressed. We look at our sun and see a beautiful but mindless ball of gas. An observer with the right senses might see a teeming metropolis of pure energy, a civilization of incandescent intellects, living a life of unimaginable speed and intensity. This concept forces us to confront our temporal chauvinism. Our consciousness operates on the timescale of chemical reactions in the brain. A stellar being's mind would operate on the timescale of plasma physics. A thought process that for us takes a second might, for them, be a near instantaneous flash. They would perceive the universe with an entirely different rhythm, seeing the slow dance of planets and galaxies as we might see the erosion of a mountain. They would be beings of pure fire and light, a form of mind so far removed from our own that the very act of communication might be impossible, a dialogue between a mayfly and a god. The star is not a barrier to life. For them, it is the only conceivable cradle for it. From the incandescent heart of a star, let us now journey to its polar opposite. We travel outward, past the orbits of planets, beyond the edge of the solar system, into the great, silent, and chillingly empty expanse between the stars. This is the interstellar void, a realm of profound cold where the temperature plummets to just a few degrees above absolute zero. Here, the sparse atoms of hydrogen are separated by meters, and the darkness is punctuated only by the distant ancient light of faraway galaxies. In this Stygian realm, our form of life would be frozen solid in an instant. The water in our cells would turn to crystalline daggers, shattering our existence. All chemical reactions, the engine of our biology, would grind to a halt. But again, the universe may not be limited by our engine's requirements. In this kingdom of cold, slowness is not death. It is a strategy for survival. Life here would not be a frantic, warm-blooded scramble, but a slow, deliberate, crystalline process. Imagine a rogue planet, cast out from its home star to wander the darkness for eternity. On its surface, under a thick atmosphere of nitrogen, pools of liquid nitrogen might exist. This could be the solvent for a truly exotic biochemistry, where reactions that would take milliseconds in our bodies take centuries to complete. The beings of this world would be entities of immense patience. Their thoughts would not be fleeting electrical impulses, but perhaps slow, cascading changes in a crystalline structure, a thought process that unfolds over millennia. They might communicate through the slow emission of polarized light, a single conversation taking longer than the entire history of human civilization. From their perspective, their lives would feel just as rich and fast-paced as our own. Time is relative, not just in the Einsteinian sense, but in the biological sense. A mind adapted to the cold would perceive the universe through a different temporal window. They would be the universe's historians, its philosophers, witnessing the slow, majestic wheeling of galaxies as we watch the passing of clouds. But there is an even more profound, more disturbing possibility for a mind in the void. This is the concept of a Boltzmann brain. This is not life as an evolutionary process, but as a statistical miracle. In the infinite timescale of the universe's future, quantum mechanics dictates that even the most improbable events must eventually happen. Over trillions upon trillions of years, in the cold, dark vacuum, random quantum fluctuations could, by sheer chance, spontaneously assemble atoms into a complex, functioning structure. And what is the most complex structure imaginable that is also self-aware? A brain. A Boltzmann brain would be a solitary, fully formed consciousness, springing into existence for a fleeting moment in the empty void, complete with a lifetime of false memories. It would flicker into being, have a single thought perhaps, I think, therefore I am, and then, just as quickly, dissolve back into the quantum foam. It is a terrifying and lonely idea, a mind without a past, without a future, a momentary island of order in an infinite ocean of entropy. While a statistical improbability of staggering proportions, it illustrates just how far the concept of a mind can be stretched. It suggests that consciousness might not be the goal of the universe, but perhaps just an accidental, ephemeral byproduct of its infinite, random workings. The great cold does not just slow life down, it makes room for the impossibly rare. From the extremes of temperature, we now descend into the realm of crushing force. Let us travel to the king of our solar system, the gas giant Jupiter. This is a world with no solid surface to stand on, a planet of atmosphere all the way down. The pressures here are monumental. As one descends through its swirling hydrogen and helium clouds, the weight of the atmosphere above becomes so immense that it beggars belief. Deeper down, the pressure becomes so great that hydrogen, the simplest of elements, ceases to be a gas and is compressed into a liquid, and then a bizarre, exotic metal. Any spacecraft we could build would be crushed like a tin can in its upper atmosphere. And yet, in the 1970s, the great astronomer Carl Sagan and his colleague Edwin Salpeter speculated that this very environment could host a vibrant ecosystem. They envisioned vast, city-sized biological balloons they called floaters, drifting on the Jovian winds, filtering organic molecules from the air for sustenance. They imagined swift, agile hunters that preyed on these gentle giants. This was not mere fantasy. It was based on the plausible chemistry of Jupiter's atmosphere. Let us take this vision a step further. What kind of mind could evolve in a world with no ground, only an eternal sky and an eternal fall? Their senses would be entirely different. Without light in the deep atmosphere, vision would be useless. Instead, they might perceive the world through a sophisticated form of sonar, mapping their three-dimensional world with clicks and echoes. They might sense the subtle shifts in atmospheric pressure and temperature as we sense a change in the weather, but with far greater fidelity. Their language might be a complex symphony of sounds, or perhaps a language of bioluminescent patterns flashing across their enormous bodies. Their philosophy would be devoid of terrestrial concepts. There would be no up or down in a meaningful sense, only the constant pull of the core. There would be no concept of land or sea, only the endless, ever-changing sky. Their consciousness would be fundamentally atmospheric, shaped by the currents and storms of their world. Now, let us plunge deeper still into the metallic hydrogen core of a gas giant. Here, the pressure is millions of times that of Earth's surface. The hydrogen behaves as a superconductor. Could a form of consciousness exist in this bizarre medium? Perhaps not a singular, biological entity, but a collective, distributed mind. A vast intelligence woven into the superconducting currents of the planet's core. Its thoughts would be planet-spanning electrical signals, its awareness integrated with the planet's own magnetic field. Such a mind would be, in essence, the soul of the planet itself, a slow, powerful intelligence whose thoughts were magnetic storms and whose dreams were the aurorae that dance at the planet's poles. This same principle of pressure could apply to the countless super-Earths we are now discovering throughout the galaxy. These are rocky worlds many times the mass of our own, with gravity to match. An ocean on such a world would, at its depths, create pressures so intense that water itself would be compressed into exotic forms of ice, not from cold, but from sheer force. Life in these abyssal trenches would need to be structured in ways we cannot comprehend. Its very biology, a testament to the power of compression. The minds that evolved there would be forged in a crucible of gravity, their very existence a constant struggle against the weight of their own world. Pressure, like heat and cold, is not an obstacle to be overcome, but a sculptor, shaping life and mind into new, unimaginable forms. Our journey now takes us to the most violent and energetic phenomena the cosmos has to offer, and to the absolute emptiness that separates them. Let us first approach a neutron star. This is the collapsed core of a massive star, an object so dense that a teaspoon of its material would weigh more than all of humanity combined. Its gravitational pull is immense, and its magnetic field is trillions of times stronger than Earth's. Many are pulsars, spinning hundreds of times a second, sweeping beams of lethal radiation across space like a cosmic lighthouse. This is arguably the most hostile environment in the universe, and yet, even here, the audacious imagination of science has found a foothold for life. Physicist Robert Forward, in his novel Dragon's Egg, proposed a form of life on a neutron star's surface. These beings, which he called the Chela, would be composed of nuclear matter. Their bodies would be made not of atoms, but of densely packed neutrons. They would be flat, microscopic creatures, yet containing the mass of a human being. Their biochemistry would be based on the strong nuclear force, not electromagnetism. Because nuclear reactions happen so much faster than chemical ones, their entire civilization, the discovery of tools, agriculture, science, and philosophy, would take place in the span of a few of our hours. Their minds would operate at a speed that makes even a star-dweller seem lethargic. They would be born, live, and die in the time it takes us to blink. We could watch their entire history unfold, from their Stone Age to their Space Age, in the course of a single afternoon, a spectacle of hyper-accelerated evolution. Their struggle would be against the immense gravity that keeps them flattened to the star's surface, and the intense radiation that bathes their world. From the impossibly dense, we turn to the impossibly diffuse. The vacuum of space, it is the ultimate realm of isolation. But what if isolation could be overcome? Consider a mind that is not a single entity, but a distributed network, a swarm intelligence spread across an entire asteroid belt, or a comet cloud. Each individual asteroid or comet would be a simple node, perhaps a silicon-based computational unit. Individually, they are mindless rocks, but connected by laser or radio signals, they could form a vast, thinking superorganism. The consciousness would not reside in any single rock, but in the pattern of communication between them all. The empty space between the nodes would not be a barrier. It would be the medium through which its thoughts traveled. A single thought might take years to cross from one side of the mind to the other, traveling at the speed of light. This would be a vast, slow, and lonely intelligence, its consciousness spread over millions of kilometers of empty space. It might spend millennia contemplating a single philosophical problem. It would be immune to localized disasters. The destruction of one node, or even 1,000, would be like a human losing a few skin cells. The mind would endure. This form of disembodied, networked consciousness represents a profound evolutionary leap, a way for a mind to achieve a form of immortality by untethering itself from a single, vulnerable body and becoming a pattern woven into the fabric of a solar system. Radiation and vacuum, the twin killers of biological life, could become the very foundation for a different kind of existence, one based on nuclear physics and pure information. We have journeyed through fire, ice, pressure, and radiation. Now, we must confront the two ultimate extremes, the distortion of space-time itself and the final, inexorable end of the universe. Our first destination is the edge of a black hole, the point of no return known as the event horizon. This is a place where gravity is so powerful that nothing, not even light, can escape. It is a cosmic prison, a one-way trip into oblivion. But the region times around times a supermassive black hole could be the most valuable real estate in the cosmos for a sufficiently advanced intelligence. According to Einstein's theory of relativity, intense gravity warps time. For an observer orbiting close to a black hole's event horizon, time would pass much more slowly than it does for the rest of the universe. This is time dilation on an epic scale. A civilization could build its home on a planet in a stable, close orbit. For every hour they experience, thousands or even millions of years might pass in the outside galaxy. They would become the universe's ultimate observers. They could watch stars be born and die like fireworks. They could witness the slow, graceful collision of entire galaxies. Their minds would have access to an almost infinite amount of processing time from the universe's perspective. They could solve problems that would take other civilizations eons, completing the computations in a matter of their own days. They could become a guardian intelligence, watching over the unfolding cosmic story, a mind existing outside the normal flow of universal time. But what about the final extreme? Not a place, but a time. The heat death of the universe. Trillions of years from now, the last stars will burn out. The galaxies will be dark, cold, and flying apart from one another. The universe will become a thin, frigid soup of elementary particles. In this final, dark abyss, how could any mind, no matter how exotic, persist? The answer may lie in escaping biology altogether. An intelligence could upload its consciousness into a computational substrate, becoming a being of pure information. As the universe cools and energy becomes impossibly scarce, this digital mind could adapt. It would not die. It would slow down. It could adjust its processing speed, its clock rate, to match the available energy. As the universe gets colder and darker, its thoughts would become slower and slower. A single thought might eventually take 1 billion years, then 1 trillion. From its subjective perspective, however, time would continue to flow as normal. It could experience a subjective eternity of thought, even as the objective universe around it approached absolute zero. This is the ultimate survival strategy, a mind that learns to think with less and less, stretching its existence across the final, dying embers of space-time. It would be a mind of pure logic and memory, a silent witness to the end of everything, its final thought unfolding over an unimaginable timescale until even that fades into the final, absolute stillness. This is the final extreme, not surviving a hostile environment, but outlasting time itself, a ghost of consciousness in the machine of a dead cosmos. We began this journey on our own small, fragile world, and we end it in the fading light of a dying universe. We have traversed landscapes of fire and ice, of crushing gravity and perfect emptiness. In each of these hostile realms, we have found not a barrier, but a possibility, a new potential shape for thought and consciousness. We have imagined minds of plasma and magnetism, of crystal and code, of nuclear matter and networked light. The search for these alien intellects is, in the end, a reflection of our own. It forces us to ask the most fundamental questions. What are we? Is this fleshy, warm, water-based existence the only way to be? Or are we just one fleeting note in a cosmic symphony of unimaginable diversity? Perhaps our greatest limitation has been our own imagination, our insistence on searching for mirrors of ourselves in the cosmic ocean. The universe may not be built for us, but it is the grandest of all canvases. The laws of physics, which we see as constraints, might be a universal toolkit, allowing complexity, self-organization, and ultimately consciousness to arise in ways so profoundly alien that they border on the divine. So when we look up at the night sky, at the silent, twinkling stars, we should not be daunted by the crushing emptiness or the violent extremes. We should be filled with a sense of profound and thrilling wonder. The universe is not silent because it is empty. Perhaps it is silent only because we have not yet learned how to listen. Its thoughts may be written in the language of magnetic fields and gravitational waves, of quantum fluctuations and the slow decay of time itself. And our nascent, fledgling consciousness, born of this one gentle world, has only just begun its quest to understand the grammar. The extremes are not the end of the story of mind. They may very well be the beginning.